Alrighty then. So we are on that in this last regular module, and you probably have noticed you don't have your project up yet. I'm going to talk about it a little bit today. Probably the due date will just have to spill over into next week. Not a big deal there. Because really what we want to do with this last bit is give you some idea of what you need to talk about and go through for your final project. Okay, so it's this multiple regression stuff. You don't have to use multiple regression in your final project. However, the ideas that we talk about in the multiple regression, when you have all these confounding variables and so forth, that you do want to talk about. Okay, so that's where this is, I guess, at least mildly important. And I think the kind of best way to go through this is to look at some data. So let me actually start here, and we'll make that a little bigger. So the open intro statistics text, now actually we use, it's the same authors, they just move things around a little bit. So this is data that they maybe talk about in places in our text as well. But this has to do with some birth weights, and so they have various columns. They have the father's age, the mother's age, the weeks at which the mother gave birth, whether or not the birth was premature, the number of visits to the hospital, weight gained by the mother, birth weight of the baby, gender of the baby, and then whether or not the mother was a smoker. And so, taking a data set like this, possibly, and I'm just going to pick the smoking thing, possibly what researchers were interested in was, does smoking by the mother appear to have something to do with the birth weight? Is there some sort of association? And so you could imagine, though, that these other variables might be confounding variables. Now, depending on how much you know or don't know, father's age. I don't know. But it was recorded. Maybe it has something to do with it. And actually, I'm just kind of glad it was recorded because we can look at some aspects of this. Mother's age, the weeks, and I guess while I talk about them, I'm going to list them on the board and then come back to the board. So we've got father's age, mother's age, weeks, so number of weeks of pregnancy, premature, number of visits, weight gained, the weight of the baby, which is what we're actually interested in, the gender of the baby, and then finally whether or not the mother was smoking, which is also what we're interested in. So I'll switch back. Well, real quick, let me go to the data file. And so you might get a data file that looks something like this. And, this is a nice data file to kind of talk about your projects, because notice that, well, if I make it a little bigger yet, notice that under visits there's an NA, not available or something like that. Missing data or bad data, who knows for sure, but they put an NA as in not available. And if you go down here further, you see a lot for the father's age, a lot of missing data. And actually, we could come back to that. I did things in a slightly different order than I might have had I, if I really, I guess if this was my project with these data, I would probably come back and change what I did for this class, okay, because, and we'll see why in a minute. Okay, so what we will, where am I? Okay, there I am. Okay. So we have those different columns, different variables, and as we look at them, right, this one's numerical. This one's categorical. Number of visits is numerical. The weight gain, numerical. The baby weight, numerical. The sex of the baby or the gender, categorical. And whether or not the mother smokes is categorical. Okay, and what we're interested in, our question, is the question of, is weight associated with smoking? Okay, and in particular, we're going to look at it through the linear regression model, although since smoking's categorical, right, I could just go to an analysis of variance because I've got a categorical explanatory variable and a numerical response variable. And so that sounds like an ANOVA, okay, an analysis of variance. However, I've got all these other confounding variables. And it would be nice to have, I'm going to go with simple, a relatively simple way to account for them. Because in my analysis, if I simply look at those two, and that's all I do, it's not very complete. Okay? Because I've got all these other things. Now, one way to handle it would be I only look at fathers of a certain age. Maybe I narrow it down to, fathers between 30 and 35, mothers between 30 and 35. Only 40-week pregnancies, so premature just falls out right there. We don't have any if they're only 40 week. With between whatever, say 10 and 12 visits, a certain amount of weight gain. So in other words, I'm taking all those variables out and I'm saying if you are exactly this couple, okay, because we got the father's age in there, so it is a couple at that point. If you are exactly this couple, then we can ask the question about baby weight gain and smoking. Well, the problem with that is you might go down to like 3 data points, right? 3 observations. So that could be a problem. So it'd be nice to be able to put more together than that. And so, in this case, the multiple regression, what it allows is we can handle all of these variables at once. But the question is, do we want to? Now, so last week we talked about adjusted R squared and overfitting and underfitting and all that. But there's another aspect we want to look at as well, and that is we don't want to use the same variable twice, in essence. Okay, we want to look at the relationships or associations between all these different confounding variables. And so we want to do stuff like, oh, okay, I've got all these confounding variables, some things to check, and our text doesn't really go into this. Now, you know, someday you may hear somebody talk about covariance matrix. Oh, and they'll spout some things and you'll go, I have no idea what that was. We must have had a horrible statistics class. Okay? Now, all that is, in essence, okay, from an intuitive point of view, all we want to do is kind of look at, I guess I'll do it down the diagonal. So here's father's age, mother's age. I won't do all of them. Mother's age, weeks, premature. Actually, that's a good place to start and finish with that. Okay, so down the diagonal. Now, if I kind of make boxes out of these. Okay, something like that. Well, notice that like here, it's a little more obvious. What I could do is I can make a little graph here of just these two sets of data. The father's age and the mother's age. And I can look at that graph. Now, what do you think would happen if I plot father's age and mother's age like that? Generally speaking, what do you figure? If I told you the mother was 26, would you guess the father was 62? No. All right? You'd guess the father was, I don't know, between 22 and 30-ish or something like that. Right? You would, if you knew the mother's age, you'd probably have a guess as to what the father's age is, or vice versa. Oh, that's a dependency. And that's what this covariance matrix is looking for. And so, you could think of it as I make a plot and, if I look at that plot, and I could even run a linear regression on it and get an R squared, something like that. I could also get a p-value for that regression. But if I run something like that, and I just look at that plot, and I see something that looks heavily dependent, I probably don't want both of those variables in my analysis. Because one is really just a substitute for the other. And if you have a bunch of that going on, it can mess up the mathematics. I guess that's just the simplest way to put it. It can hurt the mathematics that's going on, and so you can get some pretty crappy answers. So if you think of weeks and premature, I would think that's highly dependent. Okay, because premature is defined by the number of weeks. right? So if I tell you, oh, this baby was premature, you are not going to guess that baby was 40 weeks. Because by definition, it can't be. Okay, and premature, I think these days is, well, and actually I don't know where these data came from because it may vary from country to country, but I think it's like 36 weeks. So if you're 36 weeks and you have a baby, that's premature. 37 weeks, not premature, I think is where they are these days. But actually some of you may have a better idea than I do. So, but I would think there'd be a big dependency there. And, the father's age and mother's age, I would think so as well. So this is something, as you look at confounding variables, this is a type of analysis you would want to do. I would like to probably go through and check each and every pair. That's a lot, right? So, but there are some that just make more sense to check first. And if I can throw something out, then I don't have to check it with all the others, right? So I can reduce my work a little bit. Now, so if we go back to that original data set, so we have all these columns, but maybe we don't want all those columns. And the other problem is we have, actually we've got a few things to take care of here. The NAs, we really don't want those there. I can't handle things like full-term preemie very well. I really need like zeros and ones. Okay, so these are categories. Now, I wish this data set had more than 2 levels per category or per variable. Okay, but under the premature, it's either full-term or premature. Under the sex of the baby, it's either male or female. It's just 2. Under smoker, it's smoker or non-smoker. Just 2. It would be nice to do something with 3, and maybe we can look at that, or I can do some video with that, or something, just so you can kind of see that. But again, remember, I'm doing smoker as my explanatory variable, and then weight as the response variable. And so I need to mess with my data. And so one thing I can do is, if you get data like this, because some of you for your projects, you're probably going to have to make up your own data, and we'll talk about that a little bit as well. Not today, but you might have to just make up some data. Others, you maybe have picked something that you can go find some data on the internet and use that. Again, we're not, in this project, we're not trying to get a definitive answer. Okay, to do that, we really need a year. I don't remember if it's somebody in this Tuesday's class or Thursday's class that had the research sequence. You did? Yeah, okay. So, you had a year, and probably by the time you were actually trying to finish up your study, you were feeling like you didn't have enough time. Yeah, right? And that was a year-long thing. And that's the problem, is if you're going to do a real study, just truly try to get a real live answer, it takes a long time. So for us, what we want to do, it's more like some of you are in biology. I think do they still call it? No, they call it, I don't know, Seminar 1, Seminar 2? Yeah, okay. So in Seminar 1, last I knew, they may have changed it a little bit, but Seminar 1, I think you proposed an experiment, right? And in a way, that's kind of what we're doing. We're sort of proposing, I'm not asking you to write it up as a proposal. Maybe someday I'll be able to have students do it that way. I don't know if that'd be the best way or not, but we're trying to think about a study. What would it take? So we don't have to necessarily go out and get the real data, or if you want to get some real data from somewhere, you don't have to get good data. Okay, I mean, we can just sort of take whatever we can find. But so here we have some data, and we have some problems with it that we can't analyze it yet. So I just wanted to take some time to kind of show you some things you can do. So if you get data like this, and again, I want to relate this to the final project. If you go, if you talk about collecting data, right? You say, oh, we do a survey. Well, you would get your survey back, and that survey would probably be more in the form of what's up on the board there with, things like male, female, that sort of thing, not zeros and ones. Okay? If you ask somebody to fill out a survey, you aren't going to say put a 1 for male, put a 0 for female, because you're going to get crap data if you do that. Okay? You want them to circle or fill in or something like that, male, female, whatever. So you don't, that's how you're going to get your data, is something more like this. And so you have to change it. Or definitely if you're doing an observational study of somebody else's data, you may have to change it. And so, some things you can do, you can highlight all the columns. You can go to your data and do a sort. And so, for instance, I'll sort on the smoking column because those are categorical, and I would like those to be zeros and ones. And so I say, okay. And notice, all the non-smokers are first, then the smokers. So now what I can do is, while they're all sorted like this, I could go 0, 0, like that, and then highlight that and drag it down until I get to, there we go. And then I've got all zeros in there now, and then I could do the same thing with ones. Now I'm going to undo that because for one, you really shouldn't take your raw data and change it. You should always just make a copy and change that. Now I did that. I made a copy. But we could do the same thing for premature and the gender of the baby. So we could do that. And then we could also, and this is kind of what I did, was, but we'll see in a minute, this might have also been a premature thing to do. So I highlighted, I could highlight all that, do a sort again, but this time on the father's age, because there were a lot of unknowns in there. And I could say, okay. And then I could come down here and just delete all these rows that are not full, okay, because I don't have the father's age. So I could delete those rows, again, not in my original data set, but in a copy, and I could do that. And then there was another NA here somewhere right there, and so I could also delete that row. Okay, so you could clean up your data like that. And so, here I have that clean data. So there I made a copy and I cleaned up the data, and notice, just zeros and ones in here for the categorical ones. And again, if you had more levels than just 2, you would need more dummy variables. Okay? Technically, I've I've gotten rid of the variable premature and put in a dummy variable, but since it's a one-for-one swap, doesn't really matter. Okay, but if the preemie had like critical preemie, not so critical preemie, and then full term, I would have needed two dummy variables to handle it. Okay, so I would have put, to clean up my data, I would have had to use two dummy variables instead of one categorical. Okay, so I have that, and now, some things I could do just really quickly. That's a little big on there, so make that a little smaller. Oh, there we go. So one thing I did, let me go back here real quick though. Sorry. I also rearranged the columns, and I put weight at the end because that was the response variable. So I just rearranged the columns, and I put smoking right next to weight because that was my explanatory variable that I was most interested in. Okay, so I moved them around, and so part of the final project says, talk about what your data will look like. Oh, your data is going to look something like this, right? It's going to come in something like the first page, and then you're going to clean it up to something like the second page. Now, it'll all depend on your stuff. Everybody's going to have something a little different, but that's what we mean by give us a sample of what your data would look like. Is it all a bunch of numbers? Is it some categorical things that you'll have to work with? What is it? If it comes in on surveys and you say it's all numbers, probably not. I doubt it. Well, I suppose if you were, my wife is a food scientist, so they would do surveys, and it really was, it was the kind of what they call the Likert scale from 0 to, or 1 to 5, I guess, and various things. So we get numbers, but not always. So we clean it up, and right away I could just do a plot of weight versus smoking, and it'd really be probably better as a bar graph, box plot. But this is fine. I mean, this works kind of like a box plot. And as I look at those data, I'm going to make that even just a little smaller so we can see all of it. As I look at those data, actually, just right there, my guess is it's not going to show anything, right? Because that looks pretty much like it's going to be a horizontal line for the least squares fit through those data. Anybody have a question about that? That, I just kind of look at it and I go, doesn't look like the slope's going to be much of anything there, right? Because the left-hand set, the smokers, the non-smokers at 0 there, they have lower weights and they have higher weights. And then for the smokers, they're somewhere in between. So just, it would be, I'd get more information from a box plot, but, I can kind of look at that and kind of, I'm not sure anything's going to show up there. Okay, so I do that, and I could also just right off the bat run my multiple regression, and the first thing you see is the smoking, and it has now it does have a negative slope, which says if you move, because the base case was non-smoker, so if you move from being a non-smoker to a smoker, the birth weight goes down. Okay, it's a negative slope. And we're moving from non-smoker to a smoker. Now, but if you look at the standard error below it, the standard error is actually bigger than the slope. So when I do that division, I didn't do the division there, but when I do that division, I'm going to get a number less than 1. Not significant. The p-value for that would be large. Okay, because remember, you're looking for numbers like 2, 2.5, or better. 9, 10, something like that. And so that's not looking like it would be significant. However, you have to be careful. You can actually hide a significance by having too much data in there. Okay, by having lots of repetition of things and that kind of thing. You can, as we saw in our third, right? Third? No. Second, I think it was, gosh, now maybe it was even the first. Whatever we did the nursing home data, okay, and the COVID-19, what we saw there was by not looking at the confounding, it looked like we had a relationship that really wasn't there. But then when you tossed in the confounding variable, you saw that, oh yeah, the relationship was maybe really in the confounding variable, not in this other one. And but the opposite can happen. You could actually, because of confounding variables and having all those in the mix, you could hide an association that's really there. And so it's best to kind of look through the whole problem. And here, so when I do it, the first thing I notice is it doesn't look like smoking that we can say. Now see, that's the important thing. It doesn't look like we have enough evidence to say that smoking would reduce the birth weight or improve the birth weight, make it larger. Now, but as we mentioned, got to make that smaller so we can see it. Here's weeks versus whether or not the baby was premature. And if you look at that, that definitely has a downward trend. Okay, if it's premature, you would expect fewer weeks. Well, of course you would. It's the definition. Okay, so this says we really don't want both of those variables in there. Okay, because they themselves are dependent. There's a relationship between those variables. Don't put them both in there. Now, which one do you throw out? I threw out the premature column because it has less information than the number of weeks column. Right? The number of weeks tells me the number of weeks. Premature only tells me more than 37 or less than 37. Right? So I threw out the premature column because of that. Now, I didn't go through and actually do a p-value on it and so forth. You should, but it's all a matter of time here. And now here is, again, I guess I need to make that one a little smaller. Here's mother's age and father's age. And as one would expect, yeah, you can pretty much predict the one from the other. Here's a good case where, which one's the predictor or explanatory, which one's the response. Well, I just happened to do it. Father's age is the explanatory, mother's age is the response. And the reason I did was Father's age was in the left-hand column, mother's age was in the right-hand column. It was easier to plot that way. Okay, that's the only reason. Now, there is a bit of another reason to think of the mother's age as the explanatory variable instead of the response, and that is, well, I'm talking about babies. If I'm going to keep one of the two columns and throw one of the two out, I'm going to keep the mother's age and throw out the father's age. I'm pretty sure if one is more important than the other, it's probably the mother's age. Again, it's just, in my study, I would need to say that. Now, in a really good study, I would need to prove up on that, like do a research, some sort of literature search that says, oh yeah, the mother's age is much more important than the father's age. If I could find literature that seems to back that up, then, oh yeah, that's perfect. And I say, okay, look at this. They're dependent. I am throwing out the father's age because literature says the mother's age is much more important. Oh, okay, perfect, done. And so I'm going to throw out those two columns. And so here I went to that. And actually the interesting thing is, okay, so I threw out those two columns. The smoking slope really didn't change, I don't think. Right? Here it's minus 0.16. Up here, yeah, okay, it got a little steeper. So it was at minus 0.12, I guess, 0.13. Now it's at minus 0.16. However, the standard error didn't really change. And so, the slope's still not big enough to give me a big p-value. So here's the ratios down here. And again, we're looking for numbers above 2. And really, there's not lots of data here, so I'd really look for numbers above 2.5. And number of weeks, yeah, that's not too surprising. So that looks like it's going to matter. And the mother's age looks like it might matter. But, things like the gender of the baby, didn't really matter. It's kind of small. Now notice, gender of the baby, it's a negative slope. What was the base case? Anybody notice? It was female. So what does this mean? Okay, so the base case was female, the slope is negative. What's that mean? So this is the kind of stuff you want to be able to talk about, So, right, negative slope when you go from female to male. So who's heavier at birth? The females or the males? The males at birth? But today is topsy-turvy day, so what we know you meant was females. Yeah, see, because if the base case is females, then moving to the case of the males, we had to go down. It was a negative slope. So the average of the females was higher than the average of the males. Okay, with categorical variables, again, that's how it works in the regression. Is it's an average sort of thing. So if the slope is negative in moving from the base case to the non-base case, and we can go back and make sure, but I'm pretty sure it was female was the base case. So, oh yeah, because when you sort, female comes up first. And so what I did was I said I sorted, And so, well, I sorted in alphabetical order. So the females came up first, so that was the base case. So they were the 0. And yeah, I didn't go through that sort, so you wouldn't have known anyway. But hey, yeah. But once you know that the base case is the females, then the negative slope says moving from female to male, the average weight goes down. Okay, so we could now do things like look at the adjusted R-squared that we looked at last week, and that sort of thing, to start getting rid of variables. Now here, again, remember what I said I was interested in was, does smoking seem to, is smoking a good predictor or some sort of predictor of the baby's birth weight? Right now it's not looking like it. Okay, at least we don't have enough data, something like that. Okay, but that means, as I look at these, the smallest number I have is the gender of the baby. So the first thing I would want to do is probably get rid of that. And so now, again, if I were doing this for my project, I would make copies and that sort of thing. But right now, I'm just going to click here and delete that column, which then, notice I get NAs here, so I deleted that column. I'm going to cut these and paste them in their new spot. And so, as I look at that, now the smallest number, the smallest ratio, so the smallest p-value is going to be under the smoking. Okay, but I'm not going to get rid of the smoking variable because it's my study question. Okay, and so I'm going to look at p-values, I'm going to look at adjusted R-squareds. Now my guess is, with this bad a fit, the adjusted R-squared, every time I get rid of a column, it's going to go up nicely, okay, which is what we want. But if I have to get rid of something else, then the next smallest ratio, so the next biggest p-value, is under visits. Okay, any questions about that? All right, I'm just looking at the ratios. It's 1.18 down there, and so its p-value, I don't know what it's going to be, but probably up around 0.3 or something like that. So big p-value. And so, well, yeah, that's probably the next thing I would get rid of. And so I'll delete that column. That was visits. And so, I had run now it's no good here, but I had run a little regression on weeks and I think it was weeks and visits maybe, because that's another pair that I would think, the longer you go with the baby, the more visits you're going to have. So I kind of thought, well, maybe you don't want visits in there anyway, and so I got rid of that column. And, now as I look at things, we've got a really big ratio there. That's going to be a very small p-value. And again, it's weeks. Kind of makes sense, right? That would be the strongest relationship. The longer the baby's in the womb, the bigger it's going to be. Okay, and so it's not at all surprising that that's the biggest relationship. But you see, we're still not getting anything from the smoking, still not there. And what's the smallest thing besides that is the weight gain by the mother. And so once again, I'd probably try getting rid of that. And I'd still want to look at the adjusted R-squared as well as the p-values, but get rid of that and look at those. And at this point, about the only thing we have left that might not be significant, but we could still throw it out. Even if it was barely significant, we could maybe throw it out to see what happens. But the point here is, it's a lot of what if. Okay? And this is the thing that most people fail to understand about the final project. It takes time. Okay? If you whip it together and you go, oh yeah, that wasn't bad, you probably didn't do all that you needed to. Okay? It does take time. And that's why, we give you that last week and a half to work on it. Okay? Because and why I've had you think about it for the semester and, some of these things with the tests and all that. And so, the last thing, sure, I'll try getting rid of the mother's age there just to see what happens. But it's looking like I don't have the evidence to say that there's a reduction of birth weight with smoking. And sure enough, right, I got rid of it. I can redo my columns here. Oh no, that's weeks. I just want int there. The number of weeks, very significant. Smoking, even getting rid of all that other stuff that wasn't significant either, it's still not significant in our study, the study where we have the data. Okay. Now, I could add a little more data, I realized, and so this can have to do, the order you do things can matter, right? I got rid of the father's age pretty quickly, right? And it just makes sense, right? I mean, if you know the mother's age, who cares about the father's age? Because they're pretty much going to be one and the same, very similar to each other. And so that's where most of my NAs were. That's where I had to get rid of a bunch of data, right? But if I get rid of that column, because I didn't want to use it anyway, I've got more data to work with. Okay? And those are things that you want to think about with studies. So this final project is asking you to think through a study. How would you get the data? Where would it come from? Are you going to get a lot of data or probably not so much data? Are you going to get good data or, bad data? Bad as in, at the very least, messy data with things missing, right? And you want to think about those things because the number of data are going to matter. Now, it'd be interesting. I'll have to check it out, but is if I do get rid of that father age column and only get rid of the one or two lines of data that have NAs, somewhere else. There's one line, two lines, three. So it looks like I could have, somewhere closer to 150 as opposed to 120 data items. It's not that much different, 120, 150, but it could be the difference in showing significance. Okay, so this is, today, not the funnest day in the world looking at this stuff. But this is the idea that you need to be thinking about with these studies, okay? If you mention, oh yeah, there could be these 4 confounding variables, and then you never do anything with them, not very complete. Okay, you need to talk about them because confounding can be very, very important in trying to narrow down relationships. Okay, and in this case, well, I guess it wasn't that important in the sense that no matter what we did, it didn't look like we could find that relationship between smoking and birth weight. Okay, now actually, as I understand it, that is a well-established relationship. So somebody's gotten over time, many times, if we consider it a well-established relationship, many times they've been able to show that relationship. Okay, that a mother smoking reduces the birth weight. Now, we saw indications that that might be the case because we saw the negative slope. But we didn't have enough evidence to say there really was some sort of association there. Okay, and that's the difference. We look at it, we see that negative slope, we can't get a small enough p-value. Maybe what that means is we didn't do well enough on our study. We need to get more data. We need to be more careful about confounding variables, that sort of thing. Okie doke. Well, yeah, that's probably all you can take, and we're out of time. So I will see you next Tuesday.